Если для Good morning. Let's start our lesson.
Good morning. Let's start.
Okay, today we will start from 393 page. And here we will solve, for example, first problem. What we have here, t minus 1 squared u t minus 1. U t minus 1 is 0 if t less than 1 and 1 if t more than 1. And t minus 1 squared u t minus 1 is 0 if t less than 1 and t minus 1 if t more than 1. So if we draw what we have, less than 1 is 0, it's this one line, and I forgot here squared. And if t more than 1, we have a parabola, something like this. Okay, and Laplace is t minus 1 squared u t minus 1 of s is e minus s t squared in s or t e minus s square s cubed. Is it clear? Okay.
Could you please again explain the last row? I mean, when you found the Laplace.
What number?
The very first problem, the last row. I mean, the last part of solution.
Part of it. Okay. We have here a formula. Just a minute. Let me write it. In lecture, professor gave you a formula g of t u t minus a in s is e minus s times a plus gt plus a in s. Here we have that we know that a, in our case, a equals 1. G of t is t minus 1 squared. So gt plus a is t squared.
Okay, thank you.
You're welcome. The next one, the seventh. Here we must express the given function using window and stem function and compute its Laplace transform. Okay, g of t is 0, t less than 1, t, 1, t less 2, and 1 if t more than 2. G of t equals t p12 of t plus u t minus 2. So Laplace of t is tp12 of t plus ut minus 2 s equals t times ut minus 1 minus t. Here we use the formula again, another formula, and it's equals to e minus s plus t plus 1 at s minus e to the minus 2s plus t plus 1 at s and plus e minus 2s plus 1. As here we used linearity, and what we obtain, e minus s 1s squared plus 1 over s minus e minus 2s 1 over s plus s squared plus 2 over s and plus e to the minus 2s times 1 over s. Okay, what we have here, e to the minus s minus e minus 2s times s plus 1 or s squared. Is it clear?
In the third one, u t minus 2, our gt is 1, right? So when we just t plus a, our a is 2, so when we just add t plus a, it should be Laplace of 3. Why it's 1? I didn't understand.
Okay, just a minute. What row the here, да? From here to here.
Yeah.
Okay. Here we have another formula. Not here. E to the minus 2s.
Here also should be t plus 2, I guess. And then in the third one, I didn't understand why it's a Laplace of 1.
Yes, I understand your question. Okay, let me remember why. Here we have a equals 2. Mm. Here not this formula. Let me write another formula. Just a minute. Here we have not the same formula. Why did I write wrote minus 2. Here must be t plus
T plus 2,
t plus
Yeah.
2 must be. Yes, I'm.
because the step function is shifting right
Yes,
plus
yes.
2.
I wrote here t plus 2 must be here. Thank you. T plus 2. And here we have 1. It didn't depend on t, so we write only 1. Is it clear now? I made a mistake here.
So if there is no function that depends on t's, doesn't matter. I mean, the value of a, we just write 1.
Yes, of course. We have a function here. Here, g of t equals 1. This g equals 1.
So
So for any t, it's equals 1.
right, yeah, I guess.
Okay. Another one I want to show you. It's, for example, 15. Okay. S e minus 3s, 3 times s over s squared plus 4s plus 5. S times e minus 3 times s squared plus 4s plus s, not s, this is 5, equals, let me rewrite it as e to the minus 3s times s plus 2 squared plus 1. And this equals to L minus 1 of e to the minus 3 times s plus 2 over s plus 2 squared plus 1. And I must minus e minus 3s 1 s plus 2 squared plus 1. Is it clear?
No, could you please repeat?
I want to use the formula e to the at cosine bt. What is this? It's equal to s plus a or s plus a squared plus b squared. Do you remember this formula?
Yes.
What to use it, I must to rewrite my
I got it. I got it. It's just
okay.
yeah, I got it.
And then I write what I must write. L to the minus t s plus 2 over s plus 2 squared plus 1 at t minus 3, because here we have minus 3 in the power of e, minus 2l minus 1 over
Should we write t plus 3 or I don't know,
t
just enough
t
info?
minus let me write, and then I write you to a formula what I use. No, just a minute. Plus t squared plus 1 at t minus 3. What formula do I use? L minus 1 e minus sa f of s t equals L minus 1 f of s at t minus a u t minus a. This formula I use it.
Oh,
Is it clear now?
yes.
Okay, and the answer is e to the minus 2 t minus 3 cosine cosine t minus 3, because here we have t minus 3, and let me put brackets, minus 2 sine t minus 3 and times ut minus 3. This is answer of the problem. Is it
Okay.
clear?
Yes.
The second part of the first homework. Okay, here we will, for example, the first one. Y2 primes minus 2y prime plus y equals g of t, y of 0 equals minus 1, and y of y prime, sorry, of 0 equals 1. Now plus minus 2y prime plus y equals g of t, and s squared y minus, not minus, plus s minus 1 minus 2sy plus 2 plus y equals g of t. Okay, if I s squared minus 2s plus 1 times y equals g minus s minus 1, and y equals g minus s minus 1 over s minus 1 squared. So y of t equals plus minus 1 over s minus 1 squared times g minus s plus 1 over s squared s minus 1 squared at t equals minus 1 1 over s minus 1 squared of t star L minus 1 g at t and minus L minus 1 s plus 1 over s minus 1 squared at point t. I can write here this one equals to 1 over s minus 1 plus 2 over s minus 1 squared. So e to the t times t star g of t minus e to the t plus 2e t times t, and this equals to 2t e to the t minus e t plus integral from 0 to t e t minus v g of v dv. This is answer.
No, how did you get this convolution GT? I mean,
Here I use it another formula. Let me write it. Motion. Okay. If you have L minus 1 f times g at point t, you can write L minus 1 f of t evolution in g at t. I use this formula, and this is corollary from convolution theorem.
the first one is also big F, right? I mean, the plus inverse Laplace of small ft.
Yes, you can write big F. In our case, we have G and G is Laplace of G. Okay, is it clear?
Yes.
Okay, next one. For example, 9. Number 9. Here we must use the theorem given function. Okay, s over s squared plus 1 squared. If we write Laplacian, no, not Laplacian, L minus 1, s over s squared plus 1, not squared, invalid minus 1 s squared plus 1. So the first one is cosine t, invalid sine t, and this equals to integral from 0 to t cosine t minus v sine v dv. And let me write cosine t minus v times sine v is equals to cosine t cosine v plus sine t sine v times sine v, and if we open the brackets, we obtain cosine t cosine v plus sine t sine squared v, or 1 over 2 cosine t sine v and plus 1 over 2 sine t 1 minus cosine 2v. So our integral is equals to 1 over 2 cosine t, integral from 0 to t sine 2v dv, plus 1 over 2 sine t, integral from 0 to t dv, and minus 1 over 2 sine t cosine 2 times v dv. This is not a hard integral. I write on the answer. We obtain here 1 over 2 t times sine t. This is answer. This is not hard integral. You can solve it yourself.
Which trigonometric property you've used above? I mean, cosine c minus v multiplied sine v.
This equals to this. This is famous formula of difference, cosine of difference. Here only formula, not else.
Okay.
The next one.
And about example in 7, can you show the solution of 7? I mean, the problem before this.
What number?
7, just problem before this example, this problem solution. I mean, can you show your solution to the question 7? The question that we solved just before this.
Before this?
Yeah, I mean, yeah. No, not in the book. I mean, in your solution.
Okay, seven solutions.
Yeah. Yeah, you see why? I mean, here, just below. Yeah, it's below. No, it's you're getting up.
Yeah.
It's just before 7. No, not this 7. I mean, was it 7? I don't know. Just the problem before this 9. This cosine and sine.
Okay, yes. This one.
Yeah,
Or
yes.
before 9.
Yeah, this one. Yeah. See why you've written that we have an integral f. It's just below this a little bit. Yeah, you've written that we have f t minus v, right? Our f is good. So yeah, I haven't seen this t minus v. This is also the part of the function, right? I mean, t minus v.
Yes. Here we use a formula. Again, if you want, I can write it, the formula. Just a minute. I found it. Okay, we have, here I use a formula f t times t of t, sorry, equals integral 0 t f t minus v t v dv. In our case, what we have that this one and this one. In our case, f of t is e to the t times t, and I wrote here t minus v instead of t.
Yeah, okay, thank you.
Welcome. Okay, next one. For example, number 7, delta t minus 1 minus delta t minus 3 Laplace t minus 1 minus delta t minus 3 is equals Laplace at delta t minus 1 it is minus t minus 3 it is, and we also use formula e minus s minus e minus 3s.
Could you write the formula, please?
Yes, of course. Formula here we use. Let me find it.
Just e to the power minus ca.
Mm,
Is it so?
Yes, I can find it. Oh, mm. Mm. L of f t delta t minus a at s equals e to the minus s a f at a. This is formula. In our case, if f is 1, okay,
Yeah, I got it.
okay, and next one.
Will we also solve a system of systems with delta?
Yes,
Can
of
we?
course. Let me show you another one problem.
Okay.
Not for example 19, and then I will show you the system. Problem 19. Okay. W2 primes plus 6W prime plus 5W equals e to the t delta t minus 1 if W at 0 equals 0 and W prime of 0 equals 4. Here we use Laplace transform also. Minus 4 plus 6SW plus 5W equals e to the minus s delta e to the 1. Okay, and s squared plus 6s plus 5 times w is e, what I write wrong? Sorry. Here must be e to the minus s times e. E1 minus s plus 4 and w equals e to the times e minus s plus 4 or s plus 1 times s plus 5. This equals to e to the over 4 times e to the minus s 1 s plus 1 minus 1 over s plus 5 plus
Why it became my e to the minus s? Could you please explain?
here we have 1. So it's equals e to the 1 minus s. Here we use this formula, this one formula, Laplacian of f of Laplace of, sorry, Laplace transform of f theta
So-
times delta. Instead of a, we have 1, a equals 1, f of t equals e to the t. So we have e to the minus s, and instead of delta, we write e to the t. Not,
I got
okay. And here I must write s 1 over s plus 1 and minus 1s plus 5. Is it clear?
yes.
Okay. And little w is L minus 1 of e over 4 e to the minus s 1s plus 1 minus 1s plus 5 plus 1 over s plus 1. T plus L minus 1 1 over s plus 1 minus 1 over s plus 5. And this equals to e over u, not u, sorry, e over t, e over 4, sorry, u t minus 1, Laplace, inverse Laplace transform 1 over s plus 1 minus 1 over s plus 5 at t minus 1 plus e to the minus t plus, not plus, minus e to the minus 5t. And the answer is 1 e over 4 u minus 1 e minus 1 minus t minus e minus 5 times t minus 1 plus e to the minus t plus e to the minus, not plus, minus e minus 5t. Okay, is it equal? Is it clear?
Yes.
Okay, about systems, do you have questions?
No, I mean, can we solve one system, just an example, with deltas?
What number is delta? From this homework, you want?
I don't know. Yes, maybe, because in the lecture we solved system with delta, and yeah, I see from this homework, because the new homework is from this page.
What number?
430. That's this page. 413.
Well, what problem do you want to solve?
There's no system with delta. Yeah, I see.
No, we only have with you. Let's solve with you.
Okay. For example, 13th.
Yes, okay. Number 13. what we have here, y prime minus, oh sorry, x prime minus y prime sine t u t minus p x over 0 equals 1, x minus plus y prime equals 0, y of 0 equals 1. Okay, Laplace transform give us sy plus 1 equals e minus p times s Laplace sine t plus p, and the second one is x plus s times y minus 1 equals 0.
How did you find this sine t u t more plus?
Here we use the formula. I think I wrote it before.
Yeah, I remembered. Yeah, this
Okay.
ESAs and
Yes,
just
here we have
FT plus A, right?
yes. This equals to minus sine t, and I can rewrite the system as s times x minus s times y equals minus e to the minus p times s 1 over s squared plus 1. And the second, I just put 1 to the right hand side. Okay, so what we can do? Let me plus these equations. S plus 1 times y equals 1 minus e to the minus ps 1 over s squared plus 1. So x equals 1 over s plus 1 minus e to the minus ps times s plus 1 times s squared plus 1. And here we use the method of indefinite coefficients. To write 1
sorry.
plus
Laplace of sine t plus p shouldn't be like p over sine.
I wrote here this equals to sine sine
Okay.
Times s squared plus 1. This if as plus 1 s plus 1 plus bs plus c. If you solve this, you obtain that a equals 1 over 2 s plus 1 and plus minus 1 over 2 s squared plus 1 and plus 1 over 2 s squared plus 1. So little x equals to L minus 1 over s plus 1 minus e to the minus ps 1 over 2 s plus 1 minus s over 2 s squared plus 1 and plus 1 over 2 s. Okay. This equals e to the minus t minus L minus 1 over 2 s plus 2, not plus 2, not plus 2, plus 1 minus s 2 s squared plus 1 plus 1 over 2 s squared plus 1. of t minus p times u t minus p. And this equal to e to the minus t minus 1 over 2 e minus t plus p minus 1 over 2 cosine t plus p plus 1 over 2 sine t plus p u t minus p. And this equal to e minus t minus 1 over 2 e minus t plus p plus 1 over 2 cosine t minus 1 over 2 sine t and ut minus p. We find only x, and now we must find y. Let me rewrite this system. Minus e minus ps times 1 over s squared plus 1 x plus sy equals 1. Here I multiply by s and I obtain sx minus sy equals minus e minus ps over s squared plus 1. And the second one is sx s squared y equals s. Then I minus I find difference from first, the second s plus e. Yeah, sorry. From the second, I'm minus the first. E minus ps 1 over s squared plus 1. So y equals 1 over s plus 1 plus e to the minus ps s squared plus 1 times s plus 1. And here you can also use the method of independent coefficients and find that y is L minus 1 over s plus 1 plus e to the minus ps 1 over s minus 1 over 2 s plus 1 minus s 2 squared plus 1 minus 1 over 2 s squared plus 1 at point t. And if you simplify, you obtain e to the minus t plus 1 or minus 1 over 2 e minus t minus p plus 1 over 2 cosine t plus 1 over 2 sine t u t minus p. Okay, is it clear?
Yes, it's clear.
Okay, let me finish our lesson. See you later next week. Have a
Cheers.
good
Thank you. Goodbye.
Bye.
Have a good day.
Bye.